Hello all. In this session, we discuss about the synthesis of nanomaterial. It has several approaches and methods. We will see the laser ablation. In short form, we call it as LA. We have two approaches in synthesis of nanomaterials. One is a bulk top-down method, that is, we transform a bulk material into a smaller one, or we aggregate the small atoms and molecules to form a nanostructure. In this method, the laser ablation falls in the first category, that is a bulk material. When is paused with or targeted with an impulsed laser, the bulk material is broken into a smaller particles. Particularly, we can control it into a nano size. So what is laser ablation? So laser means light amplification by stimulated emission of radiation. A laser is a device that emits light through a process of optical amplification based on a stimulated emission of electromagnetic radiation. A laser is a coherence one, is an important characteristic of a laser beam because the laser beam have wave trains of same frequencies in the same phase. Due to its high coherence, it results in extremely high power. In this laser ablation method, particularly for the synthesis of the nanoparticles, we use NdYH, neodymium, yttrium, aluminum, garnet laser. Has a high thermal conductivity than other solid state lasers. It generates a large laser pulse at high pulse repetition rates. So it is an important laser used to synthesize the nanomaterials, NdYH. Laser ablation, or otherwise it is called as photoablation. It's a process of removing a material from a solid surface by irradiating with a laser beam. At low laser flux, the material is heated by absorbed laser energy and evaporates or sublimates. But when in high laser flux, the material is typically converted to a plasma. So the target material, the laser falls on the target material, the sputtering takes place. Usually, the laser ablation refers to the removal of material with a pulse laser. But it is possible to ablate a material with a continuous laser wave beam if the laser intensity is high enough. Excimer laser of a deep ultraviolet light are mainly used in photoablation. So in this photoablation, the laser wavelength is found to be approximately 200 nanometers. Consider this diagram. In this diagram, the left hand end, there is a laser light which is entering to one end. And below that, we have a argon gas. We call it as carrier gas, which carries away the things. It is a non-reacting gas. The entire cylinder is made up of a quartz material. It is under a furnace of some 800 to 1200 degrees Celsius temperature. It's a quartz window. At the left-hand end, we have a carrier gas flowing and the laser is passing. And a black material which is in the center of the furnace is the material from which we are going to prepare nanomaterial. At the right-hand end, there is a tube. The tube is circulated with the water, which makes the tube as a cooling end. So when the laser falls on the material, the breaking of the material takes place and the carrier gas carry away the things to the another end. And over the cool end, these materials go and deposit over there. After some time, when the experiment is over, we can collect the materials at the cooler end of a desired size by controlling the laser wave. So it's a very simple method, but it is an expensive one. So the depth over which a laser energy is observed, that is the amount of material removed by a single laser pulse, depends on the material optical properties and the laser wavelength. The total mass ablated per laser pulse is referred as ablation rate. The laser pulse can vary over a wide range of duration that precisely can be controlled. And this laser ablation method has a wide industrial and research applications. So NDYAG laser, this another type of a diagram. Laser falls over the material, sputtering takes place, and water cooled collector is there to collect the nanomaterials. So it's an important method, easy method, and an expensive method, but the size can be controlled in this particular laser ablation. Thank you.